Part of this lab, we're going to be looking at how temperature can affect the equilibrium. And the temperature effects really depend on if your reaction is endothermic or exothermic. So in this first example, taking magnesium sulfate, that's not with the hydrate, just magnesium sulfate. Um, this is what we find in like hot packs. Magnesium sulfate breaks up into magnesium and sulfate ions here. This process is exothermic. Heat is released over here. So if we treat heat like a product in this case, if I increase the heat, that's like adding a product, I'm going to shift the reaction to the left towards the reactants. If I lower the temperature, that's like removing heat, then this reaction should shift towards the to the product side. So what you would see there again is, do I form, is the solid? So I'm gonna reach equilibrium. I'm going to completely saturate this solution, and I know I'm at equilibrium when I see some solid present, right? I have completely dissolved as much as I possibly can, and then there's still a little bit of solid left. That's gonna be my saturated solution. That's when I know I'm at equilibrium, because the rate of the forward reaction equals the rate of the reverse reaction, right? So I'm at equilibrium, two opposite processes happening here. This is going to dissolve into make these ions, and then the opposite process is these two ions are combining to form the solid. So when that happens, I know I'm at equilibrium. I'm going to have some solid present because both those things are happening at the same rate. So then what I want to do, so that's for magnesium sulfate. Great. We're going to deal with magnesium sulfate heptahydrate. So we didn't give you the answer yet. So we want to figure out, is this thing endothermic? Is it exothermic? I'm going to make two temperature baths. I'm going to have a hot water bath and a cold water bath, and I'm going to see what happens. What happens when if I put this in water, if I put this in hot water, I suppose I put this in hot water, do I see more solid forming, or do I see more, do I see that solid dissolving and more of it dissolving and it goes away? Then I would be on the product side. So again, your solid is on your reactant side. So if you're making solid, you're shifting towards the reactants. If you are seeing the solid dissolve, then you're shifting towards the products. So think about, is this endothermic? Is it exothermic? So up here, right, we had heat. This was exothermic. So if I increase the heat, if I add the temperature, increase the temperature, I'm going to see the reaction shift towards the reactant side. If I lower the temperature, right, I remove that heat, I'm going to see the reaction I'm going to see the reaction shift towards the product side. Does the same thing happen over here? Well, that's what you're gonna find out. So very first thing, you're going to take the 7 grams of your 7 grams of your magnesium sulfate pentahydrate, and put that in some water. Measure the temperature before and after you make that solution. So you're going to measure temperature changes here. You need your definitely need your thermometer, and then you're going to look at your system. Is it homogeneous? Is it heterogeneous? That's all they're asking there. Is it completely uniform throughout, or do you see some solid present? Does that make that homogeneous or heterogeneous? Remember those words from Chem 1. And then you're going to make a hot water bath, and you're going to, your observations, do you see the solid dissolving? Do you see more of the solid forming? So again, if the solid is forming, you have more on your solid side, on the reaction side. That means you shifted towards reactants. If you see it on the other side, if you see the solid dissolve, then you're shifting towards the products. So if heat, let's just imagine heat was a reactant. Suppose heat was a reactant, and I increase the temperature. And when I increase the temperature, more of it dissolves. Then I would know that that's endothermic. If it was endothermic or if it was exothermic and I increased the temperature, then the reaction would shift that way. So yeah, that's all you're investigating there. As far as, what's the sign of delta H? If it's endothermic, it's positive. If it's exothermic, it's going to be negative. And then how's the Kc affected? So we're changing the temperature, so we're going to affect the equilibrium constant is going to change. So if you remember what the equilibrium constant, what's the equilibrium constant really look like? It's products over reactants. Right, where's our K questions? There we go. So we have like the K is going to be the, products over reactants. So if I'm increasing in products, then my K should go up, right? Because that's, so if I make more products, if I have more of less of the solid, more of the ions, then my K should increase. If I have more of my reactants, right, K, products over reactants, my K should go down. If I make more reactants, then I'm going to have a bigger number on the bottom and my K should decrease. So a bigger K means you're product favored, a smaller K means you are reactant favored. Right, so you're going to do the hot water. So this one is just about temperature changes.